Well, thanks everybody. It's 11:01. We'll go ahead and get started. Having to introduce Doug Turnbull, a retrieval engineer, or self-described as I heard a few minutes ago, the surgeon in chief.
Search in general.
Search in general. I think I might have to use that one at some point. Doug's been in search and retrieval for over a decade, including full text search, learning, rank model search agents that generate their own code. He's previously led search at Reddit, Spotify, Wikipedia, author relevant search and AI-powered search, and advised over 100 organizations over the years, all presenting the same question: how does search actually work? And so today he's going to talk about agentic search, rethinking search away from the top 10 results. So,
Great. Thank you, everybody. So, yeah, I'm Doug. I think he basically said all this stuff, but if you want to find me, I'm basically software Doug everywhere. I'm a guy wearing a Snuggie in all of my photos. Basically, the story behind this photo is Valentine's Day. As a joke, basically probably like 20 years ago, I bought my wife and I Snuggies, maybe 15 years ago. And that's me reading a technical book, The Pragmatic Programmer, with the complimentary map light that it came with, wearing my Snuggie. So kind of looks like I'm a monk contemplating things. Written some books, done some things, helped out many different organizations, either as an employee or doing consulting or doing training. So yeah, that's kind of my life as retrieval strategist, consultant, trainer. Do a lot of RAG work and traditional search. Cool. Yeah, there we go. Oh, there we go. Cool. If you are interested in this topic, I teach a course, a paid course that's lasts over about 3 weeks called Cheat at Search with Agents. And it's basically all about agentic search. And we do everything from what I'm going to do today, which is talk about building an agentic harness that does search, up to oops, no worries, up to doing auto research type code generation to improve search relevance, query understanding with search, like all the parts of a search system enhanced through some combination of LLMs. And also LLM as a judge, that's a very hot topic. All combinations relating to search. But what's fun about the course is I feel like search is kind of an interesting place because, as you'll see today, a lot of the people I work with who are doing RAG or agentic search, they're basically almost always building a harness from scratch, even though they might not call it that. And there's a lot of parallels between what I'm going to talk about today and if you were to go build a coding agent from scratch. Same kinds of principles of feedback loops and how you create skills to help use certain query strategies, given the tools, tool design, all those good things. So that's what we're going to talk about today. I'll be giving this talk next week if you want to learn more about RAG and agentic search, just to get a preview. And yeah. So what's interesting about, I've done a lot of market research on AI and search because I'm a search person. I want to convince people that search is important. I do feel like search is important. One of the most consistent research findings that you find in the field is this notion that retrieval is maybe the main driver of AI answer quality. We've probably all had that experience where we're like researching something with ChatGPT, and if it's more than a casual answer, it kind of gets steered in a wrong direction because it didn't search effectively. How it used web search didn't work quite well. It's like one of those things that works well 90% of the time, but then that 10% of the time, you're like screaming at ChatGPT about the reality of some state of the world, and eventually you like force it to find the right thing and put it in its context. So I'm working, and of course, most of my the clients and customers I'm working with, they don't have a sophisticated web search tool like they can rely on Google necessarily. They're working in their own content inside their own four walls data warehouse situation. So their search is even worse. So it's probably degrading answer quality even worse. So this is a very common research finding out there in the space. This graph, and you can find like dozens of graphs like this, where basically from any RAG or agentic search study, where basically you have no retrieval, you get like 40% answer accuracy. You add retrieval, you get 66%. You gradually improve retrieval, it goes up to 70%. So this is if you talk to your favorite chatbot and say like, and look for these kinds of studies, like study after study after study, going back to when ChatGPT was released and we were just discovering what RAG was to modern day with agentic search and using tools and all that good stuff. And before we really dig into like what we're going to talk about today, I want to give kind of a historical perspective on the space because we've sort of how we've gotten into what RAG is something of an you might argue is something of an accident of history. If you were a person like me in search from 2017 till ChatGPT came out, people were doing people were really focused in the information retrieval space on this question answering task. So it's basically if I give you a question, can you go find the passage that correctly answers that question? And people use traditional search tools. I'm going to give you a very quick run through of all of the different like basics pillars of a search application a little bit. But people were advancing from like just simple keyword matching to a lot of people here probably know what an embedding is, but starting to more consistently use embeddings that could encode the semantics of a question, a long question, and a passage to be able to match up a question, maybe not fully from the training data to a question to an answer that is maybe looks like the training data, and able to just directly answer questions. So that comes out of there's all these papers like Attention is All You Need. You have just GPT and BERT that came out before we even recognized them as chatbots. We sort of saw them as just language models that could help answer questions. And back then, if you ask someone what AI was, this is answering a question is sort of what they weren't imagining a chatbot. They were imagining this something that I typed a question into Google and it gave me the answer was sort of what people imagine. And we all remember like Google started to have those answer boxes and things like that that seemed magical at the time. So a lot of people were focused on this, and that sort of set the stage for what came next. Of course, ChatGPT drops 2022. It immediately hallucinates. So as people know, these agents hallucinate, they make stuff up. And so we have this problem in if you I remember the first time you used ChatGPT, it's very clear it could sometimes do amazing things just based on its existing language model. And other times it was out of date or it didn't have whatever you're asking about wasn't fully as training data. It was kind of on the edges. One example of this, which is really funny, is this still happens. There's a Doug Turnbull that works in search at Ithaca, and we sort of look the same. And if you ask ChatGPT if Doug Turnbull at softwaredoug.com is the same person as Doug Turnbull at Ithaca, it will often say yes, depending on what kind of data I catch it at. So it still happens. And that's even with search, by the way, because it will go and do search and things like this. People realize that, and we may have all had this moment where it's like, first ChatGPT kind of felt like a toy, could do some basic things. And then ChatGPT really started to feel useful when it had a search functionality. And you really start to have this aha moment that like the LLM plus search is the killer combination. It's not just the chat by itself or the search by itself. It's the ability to give chat the ability to search. And that's where we got into classic RAG. I'm going to talk a little bit about classic RAG just to give you a sense of what that was. And we're now in this stage, which is most of what I'm going to talk about towards the last half of this class, where I'm going to talk about we're sort of evolving past classic RAG into a completely new paradigm that in many ways looks completely dissimilar from what we were doing with classic RAG and question answering. Classic RAG is basically an extension of the question answering paradigm and era because we were getting long prompts from ChatGPT. We would formulate a question, we would go off to a vector database and answer it. And it was sort of like the easiest thing to deploy in 2020, 2023 when all this stuff was happening. Everyone may know that like vector databases kind of went insane. Vector database is just another type of search engine that focuses on embeddings. Kind of went insane in 2022 and 2023 exactly because of this use case. And now I feel like that pendulum with the agentic search perspective is kind of shifting dramatically to the other end of the spectrum, to being more look in many ways completely differently than these like 5-6 years that we were doing this stuff. So that's the historical context, and we're going to get into agentic search today. So what I'm going to talk about today are first, I'm a bottom up kind of thinker. So I often teach, what's funny is I often teach agentic stuff to search people. I'm going to try something different. I'm going to teach search stuff to AI people today. So we're going to start with the foundation of just like basic search concepts, classic search, RAG, what that look like. Just to give everyone level set, there's probably pieces in here you know. There's pieces in here maybe you don't know, or that are at least, if you know them, they're interesting to hear from a different perspective. Then we're going to start getting into the agentic search loop. I have a notebook. I have a bunch of notebooks that we are going to play with, and I'm going to try to do some live coding, knock on wood, of some agentic search stuff and see how far we get tweaking and tuning our agentic search process. Because a lot of this stuff makes a lot more sense when you see an actual harness being built. And there is a notebook in the materials that is going to help us with that. That has a lot. I'm going to walk through what's in that notebook, what's been built, and how the options we might have to improve, iterate on that agentic harness. And that agentic harness is going to use the basic building blocks of sort of the classic search stack. And that's going to be today. We'll see how far we get and see how much I embarrass myself. So that's the goal. So yeah, we all know LLMs. We'll say these are more examples of ChatGPT. I believe I was asking it not to search, and it was just making up blog posts that I wrote. Oh, take a step back. Softwaredoug.com /AMLC right there if you want to grab. There's a Google Drive link on that page. And there's other pages like if you want to join the retrieval community or some of the other stuff that is going on in the next couple of weeks, check that out. Anyway, so we all know LLMs hallucinate. We already went through this. These are some pretend blog posts that ChatGPT is convinced I wrote. Didn't actually write them. So classic RAG was basically this idea of we have a prompt and we are asking the LLM to answer the question, and we basically append to the context some search results. And it's usually a process that the LLM is not really, in the original sense, it doesn't even really know that search is happening, and it doesn't really have agency over the search. It's just saying, here is a prompt, here is some extra context, the search results, go and answer these questions. And when I do that, you can see these are actual blog posts that I've written. And for that period of classic RAG and everything, that's what we were doing. And there's a lot of stuff in here that just looks like classic question answering, right? Yeah, this just looks like question answering. So we were putting things we were basically, and I'll talk about embeddings in a second, just to give you a quick run through. We were embedding the question, and we were embedding a bunch of units of knowledge, which we would have called chunks. And we were finding the chunks that were most similar to that prompt, and we were returning them as the context and hoping the LLM sorted it out. And this to us looked like question answering. And to do that, and these are really point at the pillars of search that we're going to talk about, you needed to take, and the classic RAG perspective was almost always focused on information. I remember back in the innocent days of 2023, all the like search my PDF startups. Uh, Basically, they kind of look like this. We took our giant documents, maybe 100 pages. We chunked them into a couple of sentences, paragraph sized chunks, and we put them into different indices that serve different purposes. The vector index I've already talked about, that's the embeddings that do a pretty good job at question answering. And then just BM25, simple keyword search, was also out there. Although people, I think, were rediscovering that as they went through this process. I'm going to talk about these things. So the first thing that comes up, and all of these are still, even though I talk about this in classic RAG, they're still very important for different kinds of agentic search purposes. So the first thing that comes up is chunking. So chunking, we need to take a giant 100-page book. Of course, we can't shove 100 pages. We can't meaningfully match on 100 on like some content in that 100 pages. We need to chunk it up into units of information. So bits of paragraphs that we can inject into an LLM's context. And people have been doing all kinds of things like just doing it on document length or trying to detect paragraphs or just doing it on pages. There's a million things people do. There's also this related concept called extractive question answering. And there's I won't walk through the notebook, but there is a notebook in the materials that is showing this. It's pretty easy to do with a model. But extractive question answering, I think in this case, this is from one of the books I wrote, AI Powered Search, where you basically this is asking a question, what are minimalist shoes? And it's giving the probability of the start token and the probability of the end token of the answer. And so this is an actual maybe chunk. And you can see here, shoes, this is actually the best start. It has a 1. And you can see other things that have different scores of how likely the model that has taken this and scored it against a question tells us this is relevant or not as a start token. And then we do the same thing with the end token. We get another set of probabilities out that says conditions is the most likely end token. And then when you look at this, you see we started at shoes. That was the most popular. And for the question, what are minimalist shoes? You see that it's shoes is the beginning, and then you go all the way to the end. Shoes intended to closely approximate barefoot running conditions is seen as the most likely answer. Now, this is useful for chunking, and I'm giving you some breadcrumbs here in case you ever get into the situation of I need to develop my own chunking. This is useful for chunking because not necessarily because you're going to somehow like pre-run a bunch of questions and extract these answers and use that as chunking, although maybe there's something there. But it's primarily useful as an evaluation mechanism. So these models, these extractive question answering models, one very common, the classic one people talk about is Roberta, R-O, and then BERT, like the model, I guess A is answer. You can use them to sort of see, you can start with some coarse chunks, like larger, take it 100 pages, maybe take it down to 10 pages, see where the answers are to questions in your test set, see if your course chunks are keeping those answers together. They're not. The main thing with chunking you want to avoid is splitting within an answer. So you don't want to split like halfway between the like shoes intended to closely approximate answer. You want to keep that together. So you can build an evaluation setup that basically lets you start with course chunks, experiment with ways of splitting them up, whether it's paragraphs, whether it's just a number of tokens, and see if you keep your answers together. And you want basically the smallest chunks that you can get that keep important answers together as a way of sort of, as ML AI people who sometimes think in loss functions or what are we optimizing for, but that's kind of in spirit what we're optimizing for. So in this case, if there was an answer that highlighted there, Bayesian BM25 calibrates to be a probability, and Bayesian BM25 calibrates BM25 to be a probability, and somehow we split that up, that's a big no-no, and we need to go back and evaluate our chunking strategy. So that's how people think through this stuff. And they come out with these units eventually that they're going to index. And there's you could go each of the main thing I want to drive, and this is true, this is very true in search. Any one of these things is a hypothesis that may work. The important thing is that you have the infrastructure to evaluate the hypothesis. And there's a million chunking strategies that you could go and find for your specific problem that may or may not make sense. So very core components are RAG chunking in classic RAG. And then once we have those chunks, we have to think in terms of how we build a search system. So we've somehow broken up content into units of knowledge that we would ideally shove into our LLM's context. Now we need to think in terms of the retrieval system itself. And when I say retrieval system, I mean vector database. You might something like Elasticsearch if you know that. I mean a relational database, think databasey, but able to retrieve things for different use cases. I'm going to stop. Feel free to stop me if there's any questions. Okay, all good. Because I just keep talking if you let me. Yeah.
In the chunking, is it ever possible that the probabilistic start end tokenizer evaluates the most likely end to a query as before the most likely start?
Oh, could the end be before the start? I don't think that happens with those types of models. I think that would be definitely. I don't think that happens very often. To give you a short answer, if it did happen, what I think is sometimes more challenging is if there's not really a good answer in the document, and you get kind of weird results from it. That can be a problem. It's sort of like if you took a question and you pointed it out a document, and there wasn't actually a good answer, its results might be weird. Like what it considers the most likely begin and end might be vaguely related to the topic of the question, but not actually an answer. That probably is a more realistic risk.
You have to evaluate that as a human, or can you pass that off to LLM's judge?
I always start with the human, and then these sorts of things, if you're grounded in human evaluation, then you can say well, how good is my LLM judge at reproducing the human labels? So I don't think you can get away from the human part, because what happens with things like LLM as a judge is it tends to do well. You sort of figure out and ground it in things that the human has labeled well, and you're like, oh, I can extrapolate this one use case. But then when you go to a completely new type of use case, you have to kind of repeat that procedure. So you kind of seesaw between okay, I got this one. This happens in search too. If I'm in search and I'm labeling search results as relevant or not to a query, you might start with dozens of queries that are human labeled, and you're like, wow, for this one case where I'm searching for just to use the e-commerce example, shoes by color, it works really well, and it can extrapolate and add other fashion items by color. But then I go and I start talking about material or something new, then I kind of have to repeat that process and be like, oh, there's a new use case here. Let me do some human labeling and understand the problem, and then let the LLM be able to get all of the thousands of other queries in that umbrella, if that makes sense. At least that's my philosophy for LLMs to judge. Cool. All right, let's keep going. So there's 3 pillars of search I'm going to talk through, 2 of which you may know, and then the third one, probably the most underappreciated and the one people don't really realize. The first one are embeddings, and probably a lot of people here are familiar with the idea of embeddings. You can go to Hugging Face and get all kinds of embeddings, right? One of the original ways of dealing with where embeddings kind of came from was if I had just a bunch of entities, I could maybe just here, I'm just assigning them random values. If I just have a bunch of entities that are like basically, in this case, questions and answers, I might also have like, they could literally be anything from like users to movies people like, or just movies. And the main goal is if I have these entities, I have some sense of what is more similar than others. And in this 3-dimensional space, I can sort of scooch together things that are similar and pull apart things that are dissimilar. And that's at the core, that's what an embedding space does. And for the longest time, when we talked about embeddings, even for things like Word2Vec or things like this, we literally were I'll talk about an encoder in a second, but we literally memorized we just enumerated all the possible things in the vocabulary, and we literally just memorized what the embedding was for every word in the language. And I'm sort of doing that here, where there is some existing set of known questions and documents, and I'm just scooching together similar things and pulling apart dissimilar things. And then if you look at this from a tabular perspective, you start to see things that are obviously dissimilar. These are just our 3D points. And we start to see things that are similar. What did Doug write about BM25, which is the type of BM25 thing? BM25 is a probability. And you can kind of see these vectors, these points are close to each other. All I've done is taken a pre-existing set of things and scooched some together and pulled some apart. And scooching is like a technical term. That's like, not really, but that's sort of there are ways you can do this with just basic geometry, even of moving points around using a training set. And then we have like things like cosine similarity, where we can literally quantify how similar something is. So in this case, this is just a simple dot product, or what's called cosine similarity, where I literally multiply dimension 1 times dimension 1 plus dimension 2 times dimension 2 and so on. If this is normalized, you literally do that and you get one of the most common similarity measures out there between 2 points. And then you do this with the dissimilar stuff, and it's not at all similar. Most of the time, three dimensions are useful for teaching. Most of the times we're talking about like 768, thousands of dimensions these days. Now, if we encounter something new in our set, but we haven't scooched together, we don't know what this is, we have to somehow, in old school embeddings, we would have to somehow wait until we had enough information on this to make a determination of what it's similar to. Information, training data, could be clicks, could be human evaluation, could be lots of other things. And that, of course, is a problem. And most modern embedding models don't work by like memorizing an embedding for every question. What most modern embedding models do is they train an encoder to build an embedding. So this works because we can encode a similarity function. We can turn a piece of text into a vector that should, after we train it, should move things that appear similar closer together and things that are dissimilar farther apart. And that helps us because we're getting an embedding that's a function of the text. We're not trying to memorize an embedding for that piece of text. And so since we maybe late 2010s, mid to late 2010s, this is basically what you expect now when you download an embedding model of the base. You expect it to work pretty well for a class of queries, or a class of documents. You might have some embeddings that work well for text queries and images as the quote unquote, when I say document, I mean the thing being searched. Or might work very well for a specific domain. Like this encoder works really well. It's been trained on legal, or maybe trained on an open data set like MS Marco, that is a question answering data set. So there are a lot of things and pros and cons to every embedding encoder that you download. And even we all may know that in a language model, every token that you're reading along there has an embedding. Language models are a kind of encoder that encode an embedding. So there's a token at every position. Here we have I think there's 16 words, 16 embeddings, each 768 dimensions. And what's also interesting is the embedding for that location. That's not just that token's embedding, it's encoding the meaning of everything around it. It's encoding a lot of information about that passage to make a prediction of what is the most likely token that would go in that location. And that creates a chunking method if you use this called late chunking, which is really cool. So this is going back to chunking. If you have at any given location in this passage an embedding that covers the meaning of the entire book or 1,000-page document, then when you take this large thing and you chunk it up, preserving the embeddings of each location, well, even though they're chunked up, the embedding of that underlying BM25 actually still captures meaning of the entire document. So this is what we call late chunking. It doesn't really matter how you split it up. And then you take an average of those, and that's how you get a chunk embedding. And this is a really powerful way people are doing chunking these days, that uses the language model to start, chunks it, and then uses the embeddings from the language model itself as the thing that you're indexing. So something else to check out. Any questions on that? Yeah.
Savings from that?
From late chunking? I don't know. I think I could see there being computational savings because you're doing that upfront. Language model chunking on a larger document and not embedding, you probably save that away. And then you could experiment. I think there would be savings definitely if you were experimenting with different chunking methods, and not just because every time you chunk, you need to re-embed the entire thing. So maybe, I think people do it more because a given chunk can still capture meaning from the entire larger document and still be small. Any other questions?
Yeah, so maybe it's a silly question. So most of this content is English language or human language, right? But if the content is not human readable, or let's say tabular data that has SKU number with a number of units, like silly business tabular data, how would that work?
That's a great question. A lot of these things depend entirely, that's where the art meets the science, because a lot of these chunking methods or embedding methods in general are very specific to a given type of content. So you'll find things that are better at tabular data and things that are better at pure passages when you're going through Hugging Face. And a lot of what you do is just try to find a model that is specific to that. I don't know. I personally haven't done a lot of retrieval just on tabular data. But I imagine that there are specific chunking and embedding approaches that are just for that, mixing tabular data with paragraphs of text.
It's SQL will do the trick, but I'm just
If by tabular data you mean literally a SQL database, that would be a different path entirely, because that might be more the just doing just purely agentic work where you're creating a tool that's helping an LLM retrieve tables of data. Yeah.
A quick question. When you do the chalking and embedding, you will have to use the exactly same one with the large language model used,
No, not necessarily. You don't have to.
but
Yeah.
tokenization we need that.
That's a good point. Probably. I haven't seen that be an issue. But yeah, if you usually want the tokenization at the chunking point, like if you were to chunk by every so many tokens, you would the main risk of you maybe you're thinking of is somehow you give where you split the chunk somehow confuses the LLM because its definition of a token is different than what you were doing. But in practice, usually people, if they're going to create chunks based on like token lengths, they'll literally just do it based on words. They're not doing like word pieces, which is the common way that an LLM or an embedding model might tokenize. Any other questions?
I have this crazy thing on my mind that
Yeah, yeah.
skipping ahead to we're headed towards agentic
Yes.
search, right? I guess I'm a little bit surprised to have embeddings as like a column of this low-level search. We did pretty good search with BM25 for
Yeah.
a long time. We felt like we'd hit the max of that, and we started doing these embeddings and like cosine similarity and stuff. And I guess like the question I want to get to, and maybe we should delay it, but like now we used to think of search as very expensive because a human has to read through these 10 results or whatever.
Yeah.
Now that your LLM is like can search 1,000 times and is cruising through results. I mean, do we need embeddings?
That is a fantastic question. So earlier I said that earlier I gave that timeline and I was like, we were on this like roll of question answering to RAG, and it was very embedding focused. But I think you're in this agentic space with people are building search. Yeah, agents can do really amazing things with simple search tools because they're like iterating and reasoning about the results and everything. I'm going to get to that. But people are doing things, and I'll talk about that too, where they're just like, could I just build search with grep? Could I just have semantic search with grep? Which, I mean, obviously for a file system and organizing knowledge in a file system, it's not unreasonable. So yeah, you're thinking along the right lines. Because I think what this agentic search thing is actually a bigger paradigm shift than the question answering to RAG thing that we've had. It's like, to me, it's a pretty big break in the information retrieval space. Yeah.
You was just talking about grep. Are you referring to like bash terminal?
Yeah.
Shebang and
Just like organizing your markdown files into a reasonable way and asking an agent, hey, I need to figure out how, I don't know, I need to figure out like my company's policy on using some type of open source, and like somewhere there's a policies thing, and agents are trained extremely well on how to use file system tools to find things in code bases. So it's not hard for it to also do that in markdown files. To a certain degree, I mean, to a certain scale, but yeah, it's not crazy. And people are building these semantic reps now, which are like kind of a semantic search command line tool that people are using to do search.
Gonna invent Lucene again.
Yeah,
At the 12th time. It's gonna be awesome.
My whole career is living with many reinventions of stuff and rediscoveries of stuff, right? So yeah, we're going to talk about BM25. And so what's interesting about this, so I'm teaching search to AI people. And what I think is really interesting about this is I think AI people, especially if you came up through the era that I've talked about, machine like question answering and RAG and all that stuff, you may have familiarized yourself with embeddings and built a vector database and built those kinds of models. BM25 is like the OG search thing that we've done forever, since late 90s. early 2000s. BM25 is just stands for literally the 25th iteration of someone tuning an algorithm on a bunch of open data sets. And it's basically when people say keyword search, they often use that interchangeably with BM25. So we're going to really talk about keyword search. Lexical search is another synonym that you hear a lot to contrast with vector search or embeddings, which is what we just talked about. So the old school search thing we used to do with search is, I mean, we still do this with search, it's not really old school, is we take some documents, we tokenize them, and we build what's called an inverted index, which literally means like take some tokens and point at the documents that are matches for that token. So we've tokenized this document. Hi, this is Doug. I'd like to complain about the weather. We have a token Doug that occurs in document 0 and 1, and weather only occurs in document 0. And we could build this up with a much larger index. And a lot of the stuff that we do in lexical search is managing the stupidity of this dumb token matching system by trying to normalize these terms, dealing with punctuation variants, getting down to the same root term.
Doug, it's the English language that's stupid.
Yes, the English language is stupid. Yeah.
So
Yes, we can complain about that too. Maybe I should change my documents to be about that kind of complaint. So a lot of lexical search, there are people who work on, I'm sure somewhere at Google, someone is working on a stemmer for like Icelandic, or they're like, if you go to one of the traditional lexical search engines like Elasticsearch or whatever, you will see an extensive list of what they call them analyzers, but they're really types of tokenizers, ways of taking text down to root forms and that kind of thing, for anything from Farsi to Chinese to English, Spanish, all the major languages, because these rules tend to be language specific. So we can normalize these, lowercase them, take them down to root forms. People also do synonyms, these kinds of things. And we'll get down to a index that is probably more in line with users' expectation of an actual, what should be considered a match for a given term. And of course, a query comes in, like Doug complaint. We got to figure out this Doug guy who keeps complaining, and we need to do something about him. So someone's coming on and they're searching for Doug complaint. And we take that through the same tokenization process. That should be a lowercase d. And we match that up to the index, and we find the documents that Doug occurs in. So this is like the core inverted index system that we have in these traditional search engines. So it's not sufficient to just get those matches. People want them to be scored by relevance. And people went through, this is basically the first several decades of information retrieval, was literally like, we have some terms, how do we score what matches are in these data sets? And there's a, if you really want to nerd out about this stuff, there is a organization conference called TREC, TREC, that for a long time has published a lot of open search data sets to help people tune their retrievers. And one of the first findings that people had when they're like, how do humans, if we look at these data sets that have been labeled with what's relevant and not, how do humans think about keyword matches? Well, one thing humans do is if you search for like Luke Skywalker, there's two terms in there, Luke and Skywalker. One of these terms is very specific, and one of these terms is very ambiguous. So Luke is very ambiguous. You have Cool Hand, if you look at a bunch of movies, you have like Cool Hand Luke, all kinds that you can imagine, Luke Wilson, stuff like that. Skywalker is very specific. It's very, it's going to occur in fewer contexts. It's only really going to occur in Star Wars movies and maybe tangentially other things, but pretty much Star Wars movies. So one of the first things people realized was, well, we should weigh the rare terms more importantly than the common terms. And this is a notion called specificity, where Skywalker occurs only in these two documents. It gets a higher, it should be, matches to Skywalker should occur higher in the ranking than matches to Luke. Obviously we have both, but after we get past things that have both, we don't want to show Cool Hand Luke. We'd rather show Star Wars stuff. So that's the first finding, and we call this how many documents that a term occurs in document frequency. And we bias towards things with low document frequency. And since we're basically taking 1 over the document frequency, we call that inverse document frequency. So we're building towards something called TF-IDF, but that IDF is just the inverse document frequency. And then, of course, the other obvious thing is like, how many times does the term occur? So that's TF-IDF, TF divided by TM's IDF. More occurrences, more relevant. So that's the core concept, and BM25 is really just fancy TF-IDF. BM25 is the 25th iteration of the best copy, best matching algorithm. It'd be cool to do some history on like who copy is and what the 1 through 24th iterations were. But what they realized was that first thing they realized is term frequency should saturate. That like, by the time you get to the 7th or 8th term, it's not really giving much more signal than when you started with the first, second, third occurrences of that. So it saturates. For a long time, Lucene saturated by taking the square root, but BM25 literally just is something like TF over TF plus K1 that creates a saturation that towards I guess whatever K1 or yeah, something like that. I think in this case, just and K1 controls the steepness, how quickly it saturates. And there's a similar intuition with document frequency. Document frequency, you kind of have this gradual taper off where it's like people realize you don't want to have a linear relationship here. You don't need to, this won't be on the test. There won't be any math. Don't worry. But this is just for your reference if you want to go look this stuff up.
Wait, so you're saying that the more documents you have with the same terms and the lower score?
In this case, this is modeling this is how rare the document is. So if you had 10 occurrences of a rare term, or let's say you had like, to use my Luke Skywalker example, let's say you had 3 occurrences of Skywalker and 3 occurrences of Luke in a document. Well, the Skywalker is very rare, so the document frequency is here. So that weight of those 3 occurrences is going to be much higher than like Luke, which is over here.
Okay. So it's within the document.
Yeah, it's like a term importance. Yeah. And you get this final formula, which is hidden by my speaky thingy, which basically is what I went through. The only thing I didn't talk about is that term frequency saturation is also taken relative to document length. So a single term in a tweet is more important than a single term in a 100-page book. That's what this D over average D term is in the denominator. The document length over the average document length. So this is a very robust way of dealing with search. And often when people talk about like building hybrid search or building search across the stuff or for agents, they often mean some combination of embeddings plus BM25. I'm going to talk quickly about this hidden third pillar that people often miss as a retrieval system, which is just metadata. And if you think about a lot of queries, this is especially true in e-commerce, but it's also true even in informational searching. Like if you ask an agent to search for something, given a stock ticker, what should come back, it's going to like do things like, well, how sensitive is this query to recency? What stock ticker is it? All of these things are metadata, both on the content and the query itself. So we have metadata, we have content. Some of these attributes maybe we've learned or we're managing ourselves. And you can think about this query not so much in terms of the text matching some, like the text matching or the embedding of the query, but really as a series of attributes. The query is really, you can think about the query as literally just a color, material, category, specification of what's relevant, right? And then you have to match up this specification of what the relevant results are to these documents and their specification. And so in each of these different dimensions, you're going to say like, okay, what are the most similar color? Which of these, if I just look at color, which are more similar? And obviously, red is an exact match. Pink you might include in the results as less similar, and green would be outside the results. And the same thing with material. Maybe you include both types of material, but you're not going to include wood. And you might do this something similar with category. Yeah, so you find closest color, closest material, closest category. And in many ways, this just looks like a vector, a kind of vector, where it's like a metadata vector query and a metadata document vector. And so a lot of people, when they talk about search, they kind of get nerded out about vectors. Maybe they talk about BM25. But then there's this third pillar of people just doing a really good job of organizing and classifying content into the right organizational structure, the right metadata, and all that stuff that in many ways is the third hidden pillar that people often miss when they're doing search work. And LLMs, let's get back to, we've talked a lot about search. We've gotten the search brain down. Let's get back to LLMs and agents. We'll see how far we get. But LLMs do a pretty good job with this now. So I'm going to start using, we're going to start using this Wayfair data set. Wayfair, the furniture store, home goods store. And previously, if I wanted to take a query and like classify it into a set of attributes, that was a 6-month machine learning project. You classic NLP and all that good stuff. But LLMs do a pretty good job of this. You can basically ask an LLM, give it a list of possible categories that your query would find the most relevant product in, and ask it to, this is just Python code, this is a Pydantic structure, ask it to return this is what we're going to ask the LLM to return. Ask it to return the search query and the category that belongs to, that a relevant product would belong to. You can literally ask it using the responses API to be like, oh, for some reason now I switched to color. But yeah, so you're a helpful assistant. Here's the query, please extract the color. And if you ask it for Azure Couch and our color maybe now is a list of like the seven primary colors, it will output blue pretty easily. So this used to be a massive project, and now people are doing this pretty routinely with LLMs. And I spend a whole day or so in my course just talking about LLM query understanding. So what does this have to do with agents? So any questions on that? That was the metadata side of things. 1.5. Yeah.
You mentioned organizing the metadata. So is that going to be like in the form of like JSON, or is it they have to?
It could be. So like it's literally like, how do I represent? It's almost like representation. If I'm a furniture store, how do I represent material?
Okay.
In a way that is in the in human language, not necessarily in embedding. Embeddings are kind of statistical, because if and this is actually really important for agents, because agents, if you talk about you want a leather couch, an agent see like, well, this one's suede and this one is like this other kind of leather, then when it gets that metadata back and it's sort of like organized in a reasonable way, an agent can talk to you about it in a structured way than if it was just an embedding, right? Because embedding is just a similarity system on a backend system that's going to rank things. It's not going to describe why things are relevant. Some of that metadata organization is useful for agents for that reason. Any other questions? Bad jokes? Complaints? Cool. So okay, we've got 35 minutes left, and you've gotten the search brain dump, how search engines work. And basically, I've spent a lot of my career mixing and matching all of the things we just talked about to make search for job search, e-commerce, blah, 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 document search. And they all usually have those three ingredients, basically. So the classic RAG looks something like this. This is how most people think about it. We have supervised similarity. We think about vectors and embeddings are almost like a supervised similarity system. They require us to train on a specific type of content. Because basically what an embedding does is it's like, oh, in my training data, this question goes with this answer. This other question goes with this answer. Let me learn an encoder for all of the questions and answers I haven't seen yet that kind of look similar so that they line up to each other. And that's a supervised task, but it's supervised usually on a focused data set. It's very dependent on the training data to do your task well. I like to think about a BM25 index as almost as like unsupervised. Like obviously it's a keyword search, and people often delineate these things between like vectors are semantic and BM25 is keyword search, and that is one dimension. But I think it's important to emphasize, like in our system, the role it often plays is this unsupervised similarity system that is kind of a lowest common denominator, works well in basically any domain without doing any training. It just is there. It's a statistical ranking system that works well for most human understanding of defensible keyword matching. You wouldn't necessarily be mad about it. And when we put all these together, we have these systems, and this is a RAG system. This is a search system I might have built in the last 15 years. This is search systems that exist today that I still work with. We have some query that comes in, question answering, and we do some like query understanding to pull out the metadata. We do some query expansion to like, oh, XYZ is a synonym of XYZ is also like, I don't know, XYZ Corp or something. We do all these pre-processing things so that when we go to these other systems with embeddings and keywords, we can pull back relevant results. And then we post-process them through all of these systems. We combine these two ranking systems with something called RRF that isn't super important, but it's a way of combining different rankers. We re-rank them with a model. We might like intentionally diversify the results so an LLM or a human gets like a complete picture. And I like to call this like thing on the right, this like thick daddy search API that like people have spent years and years perfecting how to do this. And it's basically when we're doing RAG, we're still doing this sort of like thick query understanding, re-ranking, blah, 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 search API. And now we're getting into the agentic era, the harness era. And people are realizing that, you know, earlier I gave you this picture of RAG where it's like let me just dump some context at the after the question the user asked. Now with tools and tool calling, you can start to just build the intelligence of what you're trying to do into the harness, into the skills, and give an agent actually simple search tools. So like instead of this complicated thing that's going to do query understanding and then going to like re-rank results that come back and do all this fancy stuff, you can just give it like the Lego blocks itself and let the agent figure out how to build a relevant search system. And this is actually what Michael was saying. LLMs themselves are a semantic layer. Like we've been relying on embeddings to like do the semantic search. LLMs can take a complicated question and be like, well, how would I use a simple, dumb keyword search tool or grep or something like that to take what the users ask me and try to create a regular expression to find what they need, or try different keyword searches to find what they need. Agents can take simple search tools and reason about the results. So if you have, I'm just going to use grep as a straw man. I wouldn't encourage everyone to always build every search thing with grep, so don't run away with that idea. But grep is a great illustration of this, just showing how powerful it can be. An agent can take a question like, give me the stock earnings for XYZ, and if you have all of your content organized in a file system, it can translate that into what regular expressions would I search this file system to find those answers. I think it's really good at generating regular expressions because it's basically coding is something it's trained on. It can reason about the results, realize it got something weird back, so it's almost doing its own evaluation. and then change its approach to how it's going to grep. It's like, wow, when I grep this way, I get bad results. When I grep this other way, I get actually relevant results. And can we just give it, instead of like building, earlier I described this like really complicated thing, could I give the Lego blocks basically of a lexical search tool, embedding search tool, grep, whatever, and just instead of having this big thick search API, just have an LLM, a basic based retrieval tool, and reasoning to try to let it figure out how to find relevant search results. And you might say, well, this seems to make sense for RAG and all that good stuff, and it does. Like RAG is a thing where you can imagine an agent spending a lot of tokens on trying all these different tools to put back a good answer. But even in our search bar kind of search, where we expect relatively low latency when we search Amazon, there are models coming that are, like the SID1 model, which is an agentic search model that right now takes a couple hundred milliseconds, targeted toward, it's basically fine-tuned towards search and being fast. That might be something that we might deploy on like an Amazon.com style search to just use basic retrieval tools to pull back relevant results without having to build search how we've traditionally built it. Yeah, so let's start. This is the kind of stuff where it's easier to see than to it's a bit more show than tell. Hopefully this all works. So gonna walk through some code. And this is where I expect good question. Oh, I touched something. This is where I expect the really good questions. So this code is in software.com/AMLC. I'm a link there. So basically, what I've done with this code, I have this part of my training cheat at search library. I have a bunch of data sets, search data sets I know and love well, and I'm going to use this Wayfair data set. And it's all this does is installs it, and it mounts your Google Drive, which sounds sketchy. You can comment that out if you don't trust it, but I use that to cache data, so I don't recompute and reindex a bunch of stuff. But I'm going to pull in this corpus. This corpus is just a pandas data frame. You need if you want to run this, you need an OpenAI key. And just do some processing, and you can see the corpus here, what this looks like. This is a really convenient thing to play around with the Colab notebooks because it's just like 50,000 products. We also have corpus. We also have a bunch of labels for what's relevant for different queries. As you can see what this is, we've got a nice mix of like text, title, description, some category related metadata. If we were ambitious, we might this features thing, which is a real weird key value thing that tells you basically all kinds of metadata about like these products, capacity and quartz or whatever. What we're going to do is set up an agentic harness that's going to search over this just using basic keyword search. So there's a little library this is just building a simple BM25 index called search array. And Snowball is just a tokenizer that takes things down to root terms. So we're tokenizing the product title and the product description. So all that's set up. Finally, we get to a set of categories. This is and the actual search tool. So this is the actual search tool. The important thing to note is, and if you've ever used, there are a million agentic frameworks like this where you can basically create a tool that's a Python function, and it will figure out how to call it and obey the types and everything. I have something I've stupidly hand-rolled that's part of this cheat search library, but like the OpenAI's agents library or Agentic AI, all that good stuff has kind of a similar concept. But these are the categories within the data set. So I allow for the agent. This is basically the tool the agent's going to use to search. I allow the agent to filter optionally by these categories. And it passes keywords and asks for a certain top K and retrieves them. You don't really need to know too much about what's happening here, but it's just tokenizing the query itself and scoring with BM25 in each of these fields and just accumulating some scores. And does some stuff and returns a nice JSON representation of the top results, like with the important attributes that matter. And if we search this, you can see here sort of the ranked results that come back. If I search for geometric style couch, and it's not very good actually. Like, look at that. It's giving us a chandelier. This is a funny thing with EM25. Sometimes these statistics are the document frequency of geometric is actually, it's rare in this corpus. So there's a whole side thing we could go in with search where term specificity, document frequency is not necessarily a best proxy for like term specificity. But yeah, it's not necessarily great if we just use the BM25 search. All this is doing, I'm just setting up the tool so an agent can call it. And there is a special, in here is the special specification of a function call for OpenAI to call a function, which you may have seen. And it's just enumerating the legal ways you can call parameters. It's turning the doc string into part of the prompt for how to call it. And the name is just the name of the function. And just to help her to call the tool and serialize the results back to OpenAI. We don't have to worry about that too much. But let's get into the actual search results. So we have a system prompt here. We take search queries and we use the search tool to find home goods products, look at them and their limitations, blah, 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 and some other guidance, like the general guidance is some things actually don't have, some products don't actually have categories on them. So try omitting that, try including it or omitting that. And this is, many people may not have seen what a agentic tool looks like. But when we have a tool and we're calling OpenAI, all we're doing is we're calling the responses API. We're telling it about the tools. We're not magically serializing a Python function and giving it to OpenAI. We're telling it what we can call on behalf of the agent. And all this other stuff is kind of standard stuff that we pass up to OpenAI when we're doing any of this work. Text format just tells it to structure our results in as the search results schema as like a structured Python class. And yeah, so we tell it about a tool. And the main thing that we do here, we can ignore this. This is just some reasoning traces. Anytime when we get a response, anytime we see a function call, we just call the tool on behalf of the agent. In this case, just our search tool. We get a response back, which is that big dictionary Python, the big list of search results that the tool is creating. Right, earlier we saw chandeliers, and we add that to this inputs. And this inputs is just the context that we keep appending to with that with everything that's happening in this agentic loop. Anyone, don't hesitate to stop me. There's a lot going on in this code. So, yeah. So, yeah.
So you mentioned OpenAI API. Is that paid by chance? Like you have to pay for that?
Yeah. So you need a key.
Okay.
If you ran this, it would ask you for an OpenAI key.
I thought so. Yeah, because I remember our deep learning professor at the School of Data Science, he was saying like GPT-3 is a product that OpenAI has, and you would have to have an API key for that.
Yeah.
You're like kind of stuck with GPT.
Yeah.
Too. Yeah.
Yeah. Most people have, yeah. If you work for a company, you could probably get a key pretty easily.
Ooh, very nice.
Yeah. But yeah, that's a challenge with the stuff to play around with it. So we'll give you the key.
Makes sense.
So what does search look like? Well, basically, if we run search, it's going to take a set of tools. It's going to take the initial context. Ignore agent state for now. It's going to take a model. And we're going to serialize the tools that are available to the agent. We're going to call that agent tool calling loop with the tool information, what the output should look like, the context, and the model. And it will run, return some results. And you can see kind of what it's going through. Can I run this or will it freak out?
You've done it.
So it's going through. You can see I'm printing out the reasoning, so the thinking of the model that you probably seen if you use ChatGPT. I need to use the search function for Wayfair with the query small, woven, poof. I think the category should either be decor, pillows, or furniture. It might make sense to go a straightforward call rather than parallel. So I'll use search BM blah 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 BM25. I'll set the top K to 20 to get a good number of results. And it's going through. You can see all the queries it's trying. And as it's playing around with the search tool that we gave it. Oh, it's ranking them. I like to rank things based on emoji. But it's ranking results. That's happy. Yeah. Found it, and it has a summary of founder range of small boofs, seek best, shoot, blah, blah, blah. So, yeah, it goes through, thinks about the results, and iterates on them.
That emoji thing, is that built into the, is that like, was that just autonomously?
Oh, I think if you look at the schema of what the output is supposed to be for this call.
Yeah.
Oh, actually, I think it's using some, I redefined it later down, so I think this is notebook problems. But yeah, if you looked at the schema, it's basically like,
Oh, I see, got it.
this is what I asked it to return, was like search results is a Agentic type that gives you a result summary, ranked results, and it's like doc ID grade. Any questions so far? Other questions? It's like,
We ever run into like if the function itself is running into a 429 errors, like running out of token size, etc. Will that fail the agent? It's a while loop, so
it will fail I've seen, well, I know when that happens and I have to go put money into OpenAI. So it will fail this. It will like just crap out and throw an exception. But yeah, that in this case, it will fail if you're running this notebook and you don't have enough money, if that's what you're asking. It will 429. Yeah.
I know that API, OpenAI API, that you could replace with custom models. Will it look the same? Have you tried that?
With like a local model? Like,
Yeah.
Yeah, so a very similar API, like Olama and stuff like that, have similar APIs. So yeah, you could.
Yeah, I guess to me, it's like you notice it makes a bunch of searches. And to me, this is the big difference, right? It's like we used to have to come up with synonyms on the entire data set. It's like in your Luke Skywalker example, now the LLM has the context that maybe we're talking about Star Wars.
Yeah.
It can be like Luke means Luke Skywalker. You could just never do on a
Old school search system.
School embedding system.
Exactly. So it's basically its world knowledge can just sit here and be like, well, let me use something like grep or even a simple keyword search that's untuned and just find what I need and see where that tool fails or succeeds. The downside, though, with all that iteration is consuming tokens. So if you
And these go fast.
yeah. So if you're routinely doing this, and I think that the main thing is you can get pretty good search with giving an agent simple search tools, but it's just at what cost? Whereas I think before with like RAG and traditional search, you might not have been able to get good search at all. So that's probably one of the big paradigm shifts is like how many, now we're talking about a good retrieval is like building simple tools that can help an agent that aren't wasting tokens.
Bigger topic about this world where you're like software never had marginal cost for a zillion years, and all of a sudden we're using these tools that have marginal costs, and it's like, wait, what if I don't want people searching all day because they cost me
Exactly.
12 cents every time looks for chairs? Like,
Yeah.
very weird.
Yeah. So let me walk through the rest of this experiment. There's a lot of fun stuff in here. So I compare this to just BM25. And by the way, this is pretty non-deterministic. So I've studied this pretty well statistically, but on 100 queries in this data set. This is NDCG. If you don't know, that's just a fancy search metric for ranking relevant stuff above irrelevant stuff. And if it's a 1, it's like a query is perfectly ranked against the training data. And when I talk about the eval data, I should say, it's basically stuff like this, where we have a bunch of queries that are there's a bunch for this query still launcher, we have 3,000 labeled results. Some are partially relevant. You can see one thing in there that's exactly relevant. So we're trying to get as close as possible to get the exact above the partial and above the irrelevant, obviously.
That data set generated by like humans, thumb up, thumbs downing search results or something.
Yeah. So Wayfair published this. I imagine they published their methodology. In fact, in my class, the last time I taught my class, the person who created this data set was in the class, which is fun.
That's crazy.
So he was telling me stuff like some of the queries you have to we design them. So you have to go into this data, this weird field to get some information out. I was like, oh, that's interesting. Yeah. So off the bat, you just get it. This is pretty consistent with what I see. This is bottom is just a BM25 ranker, which is a frequently, anytime you read an information retrieval paper, there's BM25 is often a baseline people site, but then just adding an agent on top of that, in my estimation, gives you anywhere from a 15 to 30% increase in NTCG, which is significant. That's like a big deal. And so a lot of what I've been doing, there's a whole path of this agentic search stuff where people are building smarter retrieval. What I've been doing looks a lot more like coding harnesses, where I'm like, how do I make the harness more effective at finding interesting and useful results? So one thing is, well, obviously I can give more tools. So I just went through all the pillars of search, like BM25, metadata embeddings. Well, I basically have all of the data embedded using mini LM, which is a way outdated but small language model people use in notebooks. But I'm just going to do a simple embedding search of that using the embedded title and doc description. If I do that, here's geometric couch, I think. We actually get sofas, which is kind of nice, but nothing says geometric. And if I do that baseline is actually a little less than BM25.
That's with just embedding in no BM25.
Yeah, exactly. And if I have a couple of experiments in here. If I run just embeddings, that gives a little boost to the embedding. And again, these improvements vary. So this is a tool calling loop with the just an embedding similarity tool. And then finally, what happens when you give an agent both tools? So an agent had 2 tools. We gave it a embedding tool, a BM25 tool. And again, I want to emphasize these numbers aren't consistent, but the pattern I generally see is it's better to give it both tools. So now an agent is like, well, let me use this embedding tool for doing semantic search of the full product title and description, and let me use this keyword search to do actual matching. And as I'm using both of these tools, they tend to help each other. The agent can kind of figure out how to give the best results.
Yeah. Do you see that it likes like flip flop tool calls, or is it just like?
Well, we can actually check. You can kind of see. Where's the? Yeah, here's one where it's embedding. I'm thinking of running an embedding search with large bases and aiming for a top K of 20. I'll also use BM25 for more lower results. My plan is to execute those searches in parallel and merge the results. So you get like BM25 search and embedding search. It literally took the keywords here. Searching the same thing, the good selection. A lot of times it's just, I don't know if it searches again or if it gives up. Yeah, then it just summarizes results. So that's the first cool thing that happens. And then we've got about 9 minutes left, so we won't be able to tune a lot of this stuff, but I do want to mention the next, so you could do tool design all day. Then there's 2 directions you can go, and they look a lot like what you do with a coding harness. One is you could build a stricter harness that basically looks at the results and has some model or LLM judge that can accept or reject the results that the agentic loop generates. That's one path. And then the other path is you could so that's like adding lots of harness scaffolding around the search so that it does the right thing and it's not as non-deterministic. The other path is skills. So I've given it all these bells and whistles. If you give an agent a tool with a lot of bells and whistles, like if I just walk up to my son and say, here's a toolbox, go fix the shed or something, I gotta have to kind of tell him what tools to use for different purposes. And that's also true for this. What a lot of people will do with agentic search, they'll kind of think of it more as like a query plan in the same way that you might think of a SQL query plan, where it's like, hey, for this kind of query, you probably should focus on the embeddings and maybe like filter to this category, whereas this other kind of query, you want to do this other thing. So those are 2 complementary things that tend to work well together when people are building search harnesses. So I go through here and I'm going to show really quickly, this is kind of fun, is create I'm cheating here. I'm going to cheat. Instead of having some LLM judge tell the agent it's doing the wrong thing, I'm going to use the actual labeled data to say, hey, you got this query, you gave me incorrect results. What happens if you give me the wrong results, I'm going to like complain at you and tell you to keep trying. So kind of like the try harder perspective, the try harder thing we always tell our coding agents to do. There's a lot of code here. Don't worry about it. There's just code for like analyzing the results, looking them up in the labeled data and giving a response back, which is what this grades function does. This commented out stuff are experiments you could run if you wanted to. And what we will do is we will change the search to basically loop, get the labeled results back, inject that into the prompt, and simulate. I mean, as a human, we've done this. We've gone to the agent, we've gone to LM and say, these results suck, you need to go and figure this out. When we do this programmatically, the LLM doesn't know if it's a human, it treats it basically as a human and really wants to please the user. And we say something like, these results can be improved. Can you look at them, fix them, get creative? Here's how I feel about the results. Please improve them. Try to find more happy results to replace the meh results, or at least meh to replace the unhappy results, which are in a better ranking with happy emojis towards the top. And it's really interesting because if we do this and we append like what the evaluated search results or what the labeled search results are. And if we do this, we basically give a query like this. This is a query that it was struggling with in the previous iterations. 70s inspired furniture, you can kind of see through all of the loops of going back how it might struggle. Actually, this one got lucky and got some good ones the first try. And it's going to go through and look at the results based on how they were labeled and try to make determinations. These are actually like, I'm not searching for proofs. Sometimes you get some weird threading stuff. Yeah. So this is a very common direction, building scaffolding around the agent. I also found if you want, a lot of the stuff is commented out. You can uncomment it and play around. For example, in this search loop, you can also have a skills dictionary that is a prompt when it sees a given keyword in the query. So for toddler, there's something like a kids prompt, how to find kids stuff. A lot of e-commerce shops, kids stuff is kind of weird because kid is its own category, but there's like couches in the kids stuff, but then we also have couch categories. So you have to kind of tell an agent how to deal with that. How to deal with a fold out, that kind of thing, what a fold out is. And sometimes it's teaching an agent what these things are and how to search for them. So you can see here, it's like thinking about it. Trying to find where it's like reflecting to this. Yeah, you can see that. For many happy emojis as possible at the top, I'll use IDs from the search results for items that clearly evoke 70s retros vibe. Like, so it's using something that was relevant to try to find other relevant things. So play around with that notebook. Hope you enjoy it. But just to wrap up, and then I'm happy to hang around for questions. I think we've talked about a lot of this stuff, but really a lot of what it kind of comes down to is with this agentic search stuff, there's kind of 3 ingredients that I like to think of. I say hooks. Hooks are part of the harness, like programmatic steering of the agent to do the right thing. Then you have skills, which is like how to use something, a prompt that how to use something that's open-ended to achieve a task. And then retrieval, the actual tool itself. So these are the kind of 3 ingredients that, at least where I see people spending most of their time. If you have a simple, and this is kind of the trade-off, if you have a really simple tool like just grep and file system, you're going to spend all your time in hooks and skills trying to like encourage it to use grep in a way that's correct for your data. For example, if you had a bunch of earnings reports from stocks on your file system as markdown files, they're probably organized in a specific way, and you're probably going to need to tell the agent how to grep through that information in a very specific way, or like say, hey, there's going to be a heading that's this thing, and it's going to give you this bit of metadata. Make sure you grep for it in this specific way. So all of your design time and engineering is going to be spent there. On the other hand, and this is honestly what, if you're ChatGPT, if you're OpenAI or you're Anthropic, you're probably doing a lot of this stuff. If you're, pretend that's not grep, but that's web search. If you're a web search, you have a, like you're Google and you're using Google, you probably don't need to spend too much time thinking about the hooks and skills. You're going to give it a question. It's going to give you a good answer and summary of information. And so when people design these things, those are the trade-offs that tend to come in with that. So with that, I will close things off and just see if there are any questions.
So
Yeah.
when you tried multimodal embedding, like Gemini embedding?
I haven't messed with it yet. Yeah, I know it's
images, videos, PDFs,
yeah,
text, you know?
Yeah.
And it's gonna create kind of space with all of these vectors. So it's very interesting.
Yeah. It's very powerful. Yeah.
Because if you even put a video in there,
Absolutely. Yeah.
And this is one place where you have to do embeddings, right?
Absolutely.
Else you're going to compare an image to a blob of text.
Yeah, there's a lot of, so there's multimodal embeddings. So I didn't really get into the bazillion retrieval techniques. But some people who are focusing on agentic search, they're all about retrieval techniques, and that's a good thing to focus on. But there are things like multimodal embeddings. There's also an emerging field called late interaction, which is a way of building re-rankers that is very different than the re-rankers. It's a bit more light. In some ways, it's more lightweight than traditional rankers. But if you want something to Google, late interaction is a fantastic thing that people are talking about with agents to kind of improve their efficiency and everything. Any other questions? Yeah.
Oh, did you try the Sid one model at all?
I haven't tried it yet. Have you tried it?
Oh, I'm asking you.
No, I haven't tried it. But stuff like that, I see. Chroma also had a model they came out with that is similar. That's about agentic search. I see that as something coming. And these things will probably be fine-tuned on specific use cases too to make them efficient. So that's the other thing. There's like a trade-off of how much you fine-tune towards the problem and then away from the general problem. So that's another thing to look at.
I see.
Yeah, hey, Doug, great demo. Thank you. So two quick questions. So do you try any controller to manage your agent? Because we could be more and more agent. Which kind of controller you can try to guide your agent to do things?
Controller, like have I tried controller to manage all my agents?
Yeah, because agent we kind of choose a tool, right?
Yeah.
To find the weather, found the stock market or whatever, found the keyword. So, but sometimes it could be multiple agents, and some agent could have overlap function. But do you have
Yeah, so I've done similar things with just I get this into this more in my course, but just sub agents and like focusing sub agents on specific tasks and having an overall controller agent that's kind of managing that, if that's what you mean. Yeah, that's a great pattern, and especially if you want to focus a sub agent on a specific problem and not get it waste tokens on. So what I've done here is I've given an agent a lot of open-ended tools, and it's going to use. If I had a sub agent that was like, you only can do embedding search, and you have to take this task of embedding search, it might do a more token efficient job and use its context more efficiently just on that specific task without being distracted by the context of the overall problem.
Have you tried also even the sub agent? Each agent may be specific LLM, different model they can call, have a different function.
Oh yeah. So
they're cheaper one to do some basic work, or maybe fancy one to do with
absolutely. There's a whole field called recursive language models that is about giving an agent a Python REPL so it has a way to program and inputting all the data that it needs on the Python REPL. But then you also give that Python REPL an LLM to call for tasks. And that's the sort of recursing. So yeah, you can absolutely do stuff like that. You can give an agent like a cheap tool to do query classification, and then under the hood could be a cheap LLM that's doing that. It's not the more expensive kind.